Future value of an annuity. This is the third of 3 modules where we introduce some shortcuts which can allow us to calculate present and future values where there are a large number of cash flows. Once again, for simplicity, we will only use a small number of cash flows in our examples. So if we have a series of cash flows and we want to know the future value as at the date of the last cash flow, then this is a general formula which will give us that. Once again, we're treating each cash flow separately and compounding them up to period N. The last cash flow occurs as at period N and therefore does not need to be compounded. If the cash flows are identical, in this case $10, and the interest rate remains the same throughout the entire series of cash flows, then we call this series of cash flows an annuity. We could still calculate the future value of this annuity by compounding each cash flow separately. So the first cash flow is compounded for 3 periods, the second for 2 periods, the third for 1 period, and the last one doesn't need to be compounded at all. However, we have a shortcut that will allow us to calculate the future value of an annuity no matter how many cash flows there are. Once again, it's important to note that what we have here is an ordinary annuity because the cash flows occur at the end of each period of the annuity. It is also possible to calculate the future value of an annuity due, but that is beyond the scope of this subject. This is the formula for the future value of an annuity, where the future value is as at the end of the annuity, when the last payment is made. The variables have the same meaning as in the previous formula. C is the constant cash flow, where the first cash flow occurs 1 period in the future at the end of the first period of the annuity. R is the interest rate per period, and N is the number of periods. So let's use an example. You're 25 years old and you have decided to make annual end-of-year deposits of $12,000 into a bank account paying 12% per annum. How much will you have when you retire at age 65? Here is the formula. We know that C is 12,000. We know that R is 12% or 0.12. We need to calculate N, but if payments occur at the end of each period and there are 40 periods of 1 year between 25 and 65, so in this case N will be 40. See if you can work out the future value of this series of cash flows. The answer is just over $9.2 million. By the way, this is once again an example of the power of compounding. The number of actual dollars that have been deposited is only 480,000, less than $500,000. But the power of compound interest over 40 years increases the retirement benefit to over $9 million. In the previous examples in the previous module and also in this example, we've assumed that interest is calculated once a year. However, we often need to make the same sorts of adjustments that we did when we were dealing with single cash flows if interest compounds more than once a year. So let's do an example of that. We will redo the previous example, but instead of making a single $12,000 deposit at the end of each year, we will make monthly deposits totaling $12,000 per year. And we'll put them into an account paying 12% per annum, compounding monthly. And then we need to recalculate how much we will have at age 65. Before we can use the future value of an annuity formula, we need to calculate the C, the R, and the N that are applicable in this case. And we need to make adjustments because of monthly deposits and monthly compounding. So if we're saving $12,000 per year via monthly deposits, what are the monthly payments? What is the monthly interest rate? And what is the total number of months for the entire investment period? The monthly deposit will be $1,000. The monthly interest rate will be 1% or 0.01. And the total number of months is 40 times 12 or 480. Here is the formula for the future value of an annuity. We now have values for C, R and N. So what is the future value of this annuity? The answer is $11.7 million. Significantly higher than the previous example, because not only do we have compounding over 40 years, but we have 480 compounding periods instead of 40. And once again, we're getting more interest on interest, and that increases the total future value.